Hello friends, this is your teacher Stephen Pero taking you through a tutorial of Principal Mathematics, and today we have a sample scenario based item about integration that we shall share, and with those remarks allow us get into the discussion tonight. Here is a sample scenario about integration. A team from a certain fisheries research institute is conducting a study on how the fish population in a section of Lake Victoria changes with time during the day. They discovered that the rate at which Nile perch are being caught by the fishermen at a landing site can be modeled by the function r into x is equal to 4 over 3 plus 5 sin x, where r into x is the rate of catch in fish per hour, and x is the angle representing the time of the day measured in radians, where x is equal to 0 corresponds to the sun rays. The fisheries team wants to know the total number of fish in tons expected to be caught between sunrise and 5,400 minutes. That is about 4 days. Task: using the knowledge of principal mathematics, help the team. So when you critically look at this function, for us to get the total number of fish caught from sunrise, that is from x is equal to 0 to the about 4 days, then we need to sum up the integral of this function. We need to integrate this very function from 0, that is from sunrise, up to about 4 days. That is ultimately 4,400 minutes. Why do we need to integrate? Because the modeled function represents the rate at which fish is being caught per hour. So since we have the function already, then to get the total number of fish caught within the interval of 0 minutes to 5,400 minutes, we have to only do one thing, and that is none other than integrate the function. So how do we integrate the function of that caliber? And this is something for us. And remember, for more sample items, call for that book, King of the Jungle. Find over 5,000 scenario-based items, over 2,000 direct questions. I repeat, call on those numbers and save for the item bank. Expected response for this very one. So for us to find the total number of fish in tons expected to be caught between sunrise and 5,400 minutes, we have to do one thing. We have to integrate the modeled function, which is 4 into 3 plus sin x, 5 sin x, with respect to time x, from sunrise x equal to 0, and basically this we shall convert it to radians, which will be 0 rad, to x is equal to 5,400 minutes, which is ultimately 90 degrees, and guess what? That will be pi over 2 rad, giving us ln 3, or approximately 1.0986 tons of fish expected to be caught between sunrise and 5,400 minutes. The question is, how do we get ln 3, which is an ultimate value of 1.0986 approximately tons? How do we integrate the modeled function? Because the function represents the rate at which fish is being caught. Now, for us to integrate this, we shall use special rules. And one of the rules we have under integration is substitution. So we shall use substitution. So under the old curriculum, we could just say, prove that when you integrate the function, that the answer becomes ln 3 for those in senior 6. If you integrate such a function, you get ln 3. How do we prove that? So in the due course, we shall see how to prove the integral that gives us ln 3, which is ultimately an approximate value of 1.0986 tons, recorded for the small places. For us to start with that, we shall use substitution, and that's tan substitution. Since we are okay with the trigonometry, how to play with tan substitution for the case of a single angle and a double angle. Since the sine x is a single angle, we shall use tan substitution of half angle. So we shall let tan of a half x be equal to t and then we differentiate both sides. When you differentiate tan a half x is a half sec squared x over 2. Now we make dx the subject. Guess what? The 2 crosses over, and I will have 2 dt over sec squared a half x. So when I try to simplify everything, remember very well that sec squared is like having 1 plus tan squared. I maintain the angle as I have x. So simplifying it back, but again, we remember very well that we decided t to represent tan over half x. Therefore, if I want tan over half squared tan squared a half, then my t will also be squared. That's why I will get dx as 2 dt over 1 plus t squared. And then when I go back to right angled triangle, please tan substitution will call for t formula. So when I go back to t formula for sine x will be 2t over 1 plus t squared. If you want a derivation, check on the video about t formula. So I have to change the limits, we know very well, because I'm integrating something with another, respecting another function. So I'm integrating with respect to time, to t, basically. So that's why I have to change all the variables that are in x to t. So in the initial integral, or the lower limit, is 0, and when I substitute it in the function, when I substitute the lower integral in this function I decided to let, what I will get is very simple. I get 0, I substitute here 0. So when I get 0 divided by 2 is 0, tan of 0 is 0, meaning t will be a 0. When I get my pi over 2, because I start with the lower limit, then I go to the upper limit. So when I get pi over 2, substitute here. Where x is, I put pi over 2, simplify everything, I get tan of pi over 4, and pi over 4 is like tan of 45, and tan of 45 gets us 1. So that's why I will have now 1. So my new limits, the lower limit will be 0 and the upper limit will be 1. So I will start now integrating the new function with respect to t when the limits are already changed from 0 to 1. And guess what? Even the function that I will be having, the new function, will be in terms of t. So substituting it back, I get the value of sine x substituted, then dx substituted. I simplify the function algebraically. The numerators will stand, and then the denominators will cancel out. So I will end up with a quadratic equation, which is 3t squared plus 10t plus 3. When I use a calculator or any other method to get factors, my factors will be 3t plus 1 and t plus 3 as the denominator, and the numerator will stand with 8 dt. Integrating, factorizing out 8, integration by parts, I beg your pardon, integration by partial fraction. If you missed that lesson, check on the video about partial fraction. We looked at all the 3 cases: repeated factor, in other words, the repeated linear factor, the linear factor, and the quadratic factor. Basically, a quadratic factor that has no quadratic factor with no linear factor. We looked at all that. When you look at this quadratic equation that has linear factors, so I will use split this by partial fraction, and when I split them, I will remain with the integrals that I can just integrate direct. With the special integral technique, when you look at these separate integrals, you realize that what I'm integrating, the denominator, when you differentiate the denominator, you get what is on the numerator. The same thing, when you differentiate the denominator, you get what is on the numerator, which is a 1 here. So basically, this will take the integral of the form ln into 3t plus 1 and ln into t plus 3. In other words, when you are integrating the derivative of the function, if you remember that, those in senior 6, you must be remembering this, and also those in senior 5 who are done with the pure integration 1 and 2, then you can still understand what I'm trying to write here. Be patient. So in other words, if you try to integrate a function of this caliber, whereby the numerator is actually the derivative of the denominator, what you get is very simple. We shall get the ln of the denominator, the ln of the denominator. And if the limits are not there, you add a constant of integral, and if the limits are there, we add, if they are there, then we substitute the limits. So integration of that, where the ratio of derivative of the function to the function itself is to be integrated, then the repercussion is given as the ln of f into x. So we shall use that model to simplify the remaining part. So on simplification, I substitute in the limits, simplify everything, I remain with ln 3, which is an approximate value of 1.0986 tons of fish expected to be caught between sunrise and 5,400 minutes. For us to maneuver this case number 1, we had to use substitution method. But still substitution, which substitution are we using? T formula. We remember very well that T formula for a single angle, then the tan should be a half angle. If it is for double angle, then the T formula becomes a single angle. We scale back to the right angled triangle, apply Pythagoras theorem, find sine, cos. If cos is the case, substitute in the T equations for the required perimeters or trigonometric ratios in the integral. Simplify everything. Please trust your algebra at this very point and take the LCMs very well, get the common factors, use special integration where necessary. Otherwise, thank you for that. And if you have found this beneficial, kindly tap on the like button, tap on the comment section, write something, tap on the share button, extend this to a friend who might be in need. Otherwise, thank you so much. Allow me wish you a nice moment. We meet again. Bye bye.